All right, good morning. My name is Dan Friedman. I'm a data center technical solutions architect. I work for Cisco. I support partners in the Pacific Northwest, and the purpose of this presentation is to be an introduction to ThousandEyes. Presentation is suitable for business and technical audiences, so let's go ahead and get started. In terms of the agenda for this presentation, I want to explain why ThousandEyes is needed, what ThousandEyes is. We'll also cover some of the architecture of the solution, typical use cases where ThousandEyes can provide business value, and then we'll talk a little bit about ordering and licensing, and I'll point you at some resources. So first off, why ThousandEyes? And before we dive into the bullet points, what do we really mean by end user experience, right? And that's coming from the very top line there. Visibility into end user experience is really the answer to why we need ThousandEyes, but let's break that down a little bit. So first we have to define end user, and end users can be internal customers or employees trying to access a business application, or it could be external customers trying to access a business service or offering. Second, we have to define experience. And here what we mean is that both our internal and our external customers expect a premium digital experience, which means that applications must run at peak performance at all times. When they don't, performance needs to be restored as soon as possible, because not doing this means a whole host of consequences, including user and customer dissatisfaction, harm to your business reputation, even lost revenue. We as IT folks want to be as proactive about solving problems as possible, but we sometimes struggle with this for several reasons. Number one, we aren't sitting at the end user machine, so we literally lack the visibility and experience that they are witnessing unless we, quote, go over there, right? Walk over to their desktop, laptop, and a lot of times with remote workers, remote branches, that's just not simple or not possible. Furthermore, the nature of connectivity between users and their applications has completely changed in recent years. So let's talk through what that means a little bit. In past times, most business applications would be purchased externally and then installed, configured, and made internally on machines that were made accessible through a centralized data center. Those machines were accessed by internal customers either via a LAN or a WAN, and by external customers via WAN or internet. And all of that is to say via private or public circuits. So in summary, applications were centralized and involved lots of private and some public connectivity to enable communications to those applications. Now, fast forward to current times, things have changed a whole lot, and today applications are highly distributed. So looking at the first 3 bullet points on this slide, the public cloud has sort of become the new data center, and that doesn't mean that data centers don't exist like they used to, because they do. It just means that not all of the applications run in the privately managed data center. Now, a lot of applications also run in the public cloud. So public cloud has sort of become adjacent to, parallel to, or sort of synonymous with data center. Also, software as a service has become the new application layer, meaning while the applications all used to run on our own privately owned infrastructure in our data center, now a lot of applications run on somebody else's infrastructure. Take, for example, Microsoft Office 365. That runs on Microsoft's infrastructure. So software that is hosted by someone else. And then finally, when we were trying to talk to those applications from wherever our endpoint was connected to the network, we used to transit the enterprise network to talk to those applications, right? And that meaning the LAN or the WAN, like we talked about before. But now, with so many applications being hosted in public cloud or by SaaS providers, the internet has sort of become the new transit mechanism to reach those applications. So, whereas in previous times, talking to our applications involved lots of private circuit connectivity, LAN and WAN, today applications are no longer centralized and they involve lots of public and some private connectivity to enable communication to those applications. So, to maybe clarify or explain that in slightly more detail, we'll look at the next several bullet points on the slide. We've already said, right, apps used to be centralized, and this just means that applications used to live close to each other and to their users, a few hops away over the LAN or the WAN. Now they live everywhere. They live in branch or edge locations, they live in data centers, they live in our cloud provider networks, they live in our SaaS provider networks. Apps are also now highly distributed, which puts distance between the user and the application. The customers leveraging those applications don't just live a few hops away anymore. They aren't accessing applications just from a LAN or WAN connected business office anymore. They're connecting from home offices, hotels, coffee shops, airports, literally anywhere, everywhere. Applications don't run on infrastructure that you own anymore, many times, right? Today, lots of apps run in the cloud service provider space or are offered directly via SaaS providers. You can't fix what you can't see. And if we think about that for a second, the first real problem is you can't see what you don't own. And yes, cloud service providers provide some monitoring tools that are cloud native to that cloud. And SaaS providers will oftentimes give you kind of a status update page as to the status of underlying service dependencies that are required to successfully run their app. But you cannot get the level of information that you need out of these oftentimes to help you with root cause analysis of impacts to your own business applications. So, number one, you can't see what you don't own, and then you can't fix what you can't see. So what this ultimately results in is the typical warm room activities. You've got storage, network, compute, virtualization, application, and executives all in a room with lots of finger pointing saying, it's not my fault, it's not my problem, because the truth is it's difficult to narrow down what exactly is the problem and who's responsible. Yet it's IT, all of those people in that room that still get the phone call and are held responsible for identifying the problem and then coordinating a fix. And that's a pretty tall order for something that you don't own and you can't see. And it is essentially this problem which ThousandEyes solves. ThousandEyes helps you see and understand problems occurring across connectivity and infrastructure you don't own, so that you can be more proactive in identifying root cause and reducing the mean time to recovery. And ThousandEyes was designed in such a way that it can do this for any application, any user, anywhere, which really means any application and any user on any network. So what is ThousandEyes? First, it is a SaaS-based network and application visibility platform. So let's break that statement down a little bit in reverse. A platform is a single central UI which provides the grounds or basis for further action. The network and application visibility means that its capabilities essentially stretch across network and application boundaries. And this is really useful because it helps you correlate in any point in time the events that are happening on the underlying network that may impact the application, or in such a case where there are no underlying events occurring on the underlying network, and therefore the problem is with the application itself. So this becomes really useful in root cause diagnosis. And SaaS-based just means there's nothing for you to install, update, or secure. This is all done for you specifically for the SaaS-based management platform. You still have to install enterprise agents and endpoint agents. You don't need to install cloud agents. You don't need to install internet insights. Those things are also taken care of for you. Now, to help illustrate where ThousandEyes belongs in Cisco's broader portfolio of products, we'll look at the first bullet point. ThousandEyes is part of Cisco's FSO initiative, and FSO stands for Full Stack Observability. FSO isn't a product, it's just a concept or an idea which involves providing visibility, insights, and action across your technology stack. This is about collecting and processing a lot of data via AI and ML to provide meaningful business visibility and insights that are beyond human scale to analyze and produce, and then offering recommendations for action which can be executed manually or via automation. Today, this is done across 3 different domains: your infrastructure, which is primarily handled by Intersight, your networks, and to some degree your applications, which is handled by ThousandEyes. And of course, your applications at a much deeper level is handled by AppDynamics. So ThousandEyes offers features such as synthetic tests, tests run on agents, cloud agents, enterprise agents, or endpoint agents, which are the execution point for sourcing network traffic. Tests are run to understand the real-time state of key IT systems and services that are impactful or potentially impactful to your business applications. And the tests are related to routing, network performance, and application performance. Another feature really has to do more with end user experience, understanding network connectivity for remote users in small office, home office locations, or remote office locations, or traveling workers, etc. Understanding the performance of the web-based applications they're trying to access via their browser, and some limited synthetic tests which endpoint agents can run when they are online, because remote user laptops are not always online. You've also got internet insights. This doesn't involve tests, at least not tests that you configure and run on your own agents, but instead it's a huge collection of data from agents all over the world, which helps to report on the status of providers and services within regions that your business runs, so you can determine if these events are impacting your business applications in some way. So those features are really the main solution components down at the bottom of the slide. And each of the tests, when they run on these agents, feed information back to the SaaS-based management platform. And that data then becomes the basis for dashboards, reports, alerts, and insights, which is the second bullet point that you see on the slide here. So dashboards are really intended to provide you near real-time data about the status of the tests that were run, which indicate the status of your network and your business applications. Reports are not about real-time data. They're more about trending data over time and looking at historical data, or even data retention beyond the point where the platform, I believe the platform only supports 30 days of data, and then it basically expunges that data from the database. So if you want to retain that data long term, you can run reports and basically keep that data offline permanently. It's also really important to set up alerts, and each of the tests basically analyzes a certain set of metrics, and those those metrics you can alert against. So for example, when you run a network test, metrics that are collected include, loss or packet loss, latency, and jitter. And maybe you want to be alerted when there's a certain amount of packet loss. So alerts help you leverage the ThousandEyes tests to become more of a proactive platform. right? You want to know when problems are happening before people start calling you and telling you that they're happening, because you want to know about it. You want to be able to say that you're aware and that you have a plan, and you're working on the problem already. In terms of how you can alert via email. So you can set up a distribution list of emails that you want to, or people that you want to send alerts to. You can alert when the alert becomes active. You can, alert when the alert becomes resolved. You can alert through a number of integrated platforms, including things like Slack and PagerDuty and ServiceNow. And you can alert through webhook, basically, which allows you to talk to any remote system. So there's plenty of mechanisms for alerting. And if you want, you can leverage the API to pull alert data out of the system and do essentially whatever you want with it. And then insights, all of that information really provides you insight into the underlying performance of your network and your application, and that's the entire point. Now, the coolest thing I think about this platform is that what's going on at one layer of your infrastructure, like the network layer, versus what's going on at the application layer of your infrastructure, these events are correlated in time, and you can actually share this data within a range of, like, let's say there's an event on your network that impacts your business application. It happens at 1 p.m. You can actually share or export what's called a snapshot, which focuses around that time, that event at 1 p.m. Within a range. So maybe 2 hours before the event to 2 hours after the event. And you can share that data with other teams and your service providers, so that everyone's on the same page about exactly what was happening at that point in time. And you can navigate back in time to see what the status of the network and the app looked like before the event, during the event, and after the event. And you can look at each individual layer. So you can look at the routing, you can look at the what's called path visualization, which is basically each end-to-end hop and what was going on there, from latency to packet loss to changes in DSCP values in your packets, that impact your real-time communications. You can understand your network metrics in terms of packet loss, latency, and jitter. You can go all the way up the stack, right, to test your web-based applications, page load times, element load times, where those elements are coming from, certain content distribution networks, and so on. So it really helps you troubleshoot and narrow down the root cause of an issue, and that helps to decrease the mean time to recovery, right? Restoring that premier or premium, user experience that we want, and also to hold service providers to their SLAs, right? Because there's money involved. If you're down for days and that's beyond the SLA that your service provider holds you to, they owe you money. So one, we hope that we never have to have that situation, but if we do, we want to be able to basically prove to the provider that it was their responsibility to keep this service online, and the reason that you were having an outage or business impact was because of their outage, in which case they do owe you money. Okay, so this summarizes what is ThousandEyes. And this slide just provides a quick visual of all of this, right? ThousandEyes provides, a unified view of performance between the user and the application. So you can see the user on the left, the application on the right. At the very bottom, you see these different icons that the ThousandEyes business unit will typically use to represent enterprise, endpoint, and cloud agents. And then in the middle, we see all of the things that ThousandEyes illuminates, right? It illuminates application performance, user experience, network connectivity issues, network topology for remote users, routing topology for all users. So just a quick visual aid. Next, we'll talk about, this says Intersite Architecture. That should say ThousandEyes Architecture. Apologize for that. So what does ThousandEyes Architecture look like? You have several agent options, okay, which are covered up at the top of the slide here. And as you'll see in the next slide, depending on the agent type and the scenario, agents are software which receive instructions from the SaaS-based management platform. They run tests, they collect data, and they send that data back to the SaaS-based management platform. That data then provides the basis for analysis and display in real-time dashboards, trending and historical data in reports, alerting, and then sharing of the data via snapshots, as we just talked about. So here we're just going to summarize the agent types, and on the next slide we're going to explain them in some depth. Cloud agents essentially sit outside your enterprise and are therefore used to monitor traffic from the outside in. So traffic headed towards applications running in your enterprise network. Enterprise agents sit inside your enterprise network and are therefore used to monitor traffic from the inside out. So traffic headed out of your network to applications that live external to your network. Endpoint agents sit on an end user laptop, which is either Windows or Mac OS, and are used to map the last mile of network topology for that user, along with end user browser experience and some limited synthetic testing. As stated earlier, all the agent types provide information back to the SaaS-based management platform. Now, we mentioned running tests, and we said that agents receive test instructions, but they also execute tests by sending traffic to target destinations. And they will either receive traffic back or they won't. And in either of these cases, they feed the result back to the SaaS platform, along with metrics which apply to the types of tests run, so that you can essentially analyze what was happening at a given point in time. Now, there are many types of tests. Some are, let's say, at lower layers of the IT stack, closer to the hardware. Some are at higher layers of the IT stack, closer to the applications. Some tests are more complex and include not only themselves, but also tests lower down in the stack. These are called nested tests. And an example of a nested test would be an HTTP transaction test, which we'll talk about in a second. And some tests are simpler, like the BGP test, which is lower down in the stack. So, listed here under synthetic test types and sizing, I list some types of tests, and this is not an exhaustive list, it's more like a summary, but we'll talk through them quickly. BGP testing allows you to understand the status of routes for given prefixes, their availability, the path to the prefix, and any updates to that path. Network tests are, there's a couple of types of network tests. There's agent to server tests, and there's agent to agent tests. The primary difference between the two is that agent to server tests are unidirectional, and agent to agent tests are bidirectional, which means sometimes the issue happening on the network is happening on the asymmetric return path. And in order to detect that, you might need a bidirectional test, an agent-to-agent test. Agent-to-server tests leverage TCP and ICMP type packets, and agent-to-agent tests leverage TCP or UDP type packets for their tests. With regards to HTTP tests, there's three types. There's HTTP server, which basically tests for any kind of response coming from the server. There's HTTP page load, which actually loads the page, the target page. It's not just about receiving a response, it actually loads content into the browser, and this gives you sort of a waterfall of different elements on the page and how long they're taking to load, and which content distribution network is serving up those elements, because you could be sourcing different elements in a single page from different providers, if you're using a content distribution network at all. And so this helps you troubleshoot, what portions of your web page are having trouble loading. Is that related to an outage with a particular content distribution network? Is it related, to something else? Is the time to load related to a network issue, or packet loss, or something like that? And then finally, there's a transaction test, which uses something called Selenium, which you essentially use a recorder to record points and clicks in a web browser that represent an actual transaction happening on a real web page. For example, making a purchase on an e-commerce site. And once that script is created, you can then load it into your HTTP transaction test, and you can run that periodically, and you can see screenshots of the status of that web-based transaction. And so this is sort of like the deepest test. And an HTTP transaction test, as we mentioned earlier, is a nested test. So it includes within it the HTTP page load test, the HTTP server test, the network test, and BGP tests. So this is, quote, an expensive test when it comes to the number of units that are consumed. We're going to explain that in just a minute. SIP and RTP tests have to do with real-time audio and video type calls. So these are often used for validating or keeping track of unified communication services such as WebEx or Zoom. And then you've got another, FTP file transfer type test that you can configure. Now, the next bullet point talks about sizing of tests, and this really refers only to tests that run on the cloud and or enterprise agent types. These agents consume units, which can be thought of as currency. Tests that run on cloud agents are twice as expensive as those which run on enterprise agents. And the reason for that is that the cloud agents run on Cisco-maintained infrastructure. So you're sort of paying for the infrastructure and the test, whereas enterprise agents run on your infrastructure. So you're already paying for the infrastructure. We're only charging you for the test. Tests that are more complex cost more units. So that has to do with the type of test. Like I was explaining earlier, a BGP test would cost less units than an HTTP transaction test. The number of agents, points of execution, tests that include more agents will cost more units. And finally, tests that run more frequently will cost more units. So it's important during pre-sales to firmly understand customer requirements and develop an appropriate strategy. We want to purchase enough units for the tool to be able to run the tests needed to provide meaningful and effective results, but without unnecessarily making the cost too high. So, for example, in most cases, it's not necessary to run a test every 1 minute. Or from every cloud agent in the world, right? Every 10 minutes will probably suffice, and from a handful of cloud agents, depending on where your external customers are, will probably suffice for most circumstances. Regardless, since cost is assigned on a per test basis, we need to know the full list of types of tests that need to be run. And then per test, we need to know the number of agents and the frequency of test runs in order to calculate the cost. Finally, at the bottom of the slide, I just want to point out some of the providers and services that many enterprises leverage as part of the architecture of delivering their own business applications. We've got internet service providers, cloud service providers, DNS services, content distribution networks, denial of service, scrubbing services, essentially, and software as a service providers. Not each business application uses all of these providers or services, but it's important to understand on a per application basis which services are used, essentially the dependencies. That way, appropriate tests can be created to monitor all of the providers and services that your application depends on, and that you're, can impact your application when there's issues with those providers and services. All right, so this starts as a blank slide. This is a quick slide that I created myself to try to explain the architecture of ThousandEyes. And, a little upfront disclaimer, this is not meant to be completely technically accurate in every aspect. It's really meant to help convey general concepts of connectivity between users and services, users and the services and applications that are leveraged, right? So in the middle, you have a representation of what would be the internet or WAN connectivity. So depending on the specific scenario, this can be public connectivity or private WAN connectivity. Usually public these days, right? As we were kind of saying earlier. On the top, you have various locations which contain infrastructure. So in the top left, you've got public cloud providers with as a service running your applications on cloud service provider infrastructure, and you may leverage public internet or private WAN connectivity to reach it. In the top middle, you've got your software as a service companies running your applications on someone else's infrastructure, and you leverage typically public internet connectivity to reach it. In the top right, you have data center, your data center running your applications on your own infrastructure, and you may leverage public internet or private WAN connectivity to reach those applications, depending on whether you're an internal or external customer. Each of these locations has routers shown in dark blue, which provide network connectivity. Now, on the bottom, you have various locations which contain users. In the bottom left, you've got your remote users, and here we show home office, but this can also be hotel, airport, coffee shop, etc. In the bottom middle, you've got corporate users. This is meant to sort of represent your traditional corporate offices, some of which share a campus LAN with a data center. So the corporate office is not always physically separate from the data center as shown in this diagram. And in the bottom right, you've got your branch office users, your edge locations. These also represent traditional corporate offices, but are smaller remote sites, right? Each of these locations also have routers shown in dark blue, which, in addition to routing, these locations typically also have wireless services available because we've got users there. So next, we'll mention some common services that companies use for various purposes, and we kind of covered this on a previous slide too. In the middle, we've got your internet service providers, DNS providers, content delivery networks, and security as a service providers. So for example, the DDoS scrubbing that we were talking about earlier. Again, this is not exactly technically accurate, but I tend to think of these services as things that run out on the internet, and so I show them here attached to the internet. In the public cloud, we have infrastructure as a service, platform as a service, and software as a service, running your business applications, and everyone knows that these are services offered by most cloud service providers. In the SaaS bucket, we have common applications like Office 365, Salesforce.com, Slack, and even unified communication as a service applications like WebEx and Zoom running. And, these can also be thought of as things that run out on the internet, but I think of these more as applications than services, so I show them under the SaaS bucket. Now that we've kind of laid the groundwork, this is where we're going to talk about ThousandEyes Architecture, which is really all about the traffic flows between users and applications. So first, you've got the ThousandEyes SaaS-based management application, which we're showing now with the red highlight up in the SaaS bucket. All ThousandEyes infrastructure components will be shown with a red highlight going forward. So next, we're going to talk about the endpoint agent. So if we look down in the home office in the lower left corner, we've just added the endpoint agent. This gets installed directly on users' Windows or Mac OS laptops, which is why we show it here with the red highlight touching the actual user, since it's very close to the actual user, right? It's getting installed on their laptop. Since the agent's installed on the local laptop, it can leverage functions of the operating system to map the local network connectivity. It will tell you whether the laptop is connected via wired or wireless, whether the laptop can reach its default gateway, what its DNS servers are, and give you a hop-by-hop visualization to the local ISP. So you can kind of understand whether there's network layer issues going on. From a synthetic testing perspective, only network and HTTP server tests can be configured in the ThousandEyes SaaS-based management application and pushed to run on endpoint agents, right? So only a fraction of the total types of tests that can be configured can actually run on endpoint agents, whereas cloud and enterprise agents can run all test types. And then technically, if really needed, you can also install the endpoint agent on user laptops in corporate or branch offices, which we're now showing. But since these are environments where the infrastructure and connectivity is usually well known, we don't typically leverage endpoint agents in these locations. So we're going to go ahead and remove those from the diagram again. Next, we're going to talk about enterprise agents. Excuse me. These agents are software components that can be installed in a variety of form factors, including on routers, switches, servers, or virtual machines. They are typically installed, as we're showing here in the diagram, in proximity to users in the corporate or branch offices, but not on their laptops. And what that really means is that these agents essentially approximate the behavior of many users inside corporate or branch offices as they communicate outbound. Remember, enterprise agents communicate inside out to services and applications that they access externally in other locations, such as in the cloud service provider, SaaS, or maybe even the data center of some other company. Next, we're going to talk about cloud agents. These agents are installed and maintained by Cisco and ThousandEyes all over the world within different tier internet service providers, DNS providers, content delivery network providers, security as a service providers, broadband network providers, etc. And what this really means is that these agents approximate the behavior of many users external to corporate or branch offices or data centers as they communicate inbound. So remember that cloud agents communicate outside in to services and applications that they access in your locations, right? So that can be your data center, your corporate office, your branch office, wherever your business applications are running that face your external customers. Now, finally, we're going to show some real-world traffic flow examples that ThousandEyes can help provide visibility into that would otherwise be pretty difficult to troubleshoot. The first flow shows an employee of your company who is maybe at home or in a hotel. They call you and tell you that they're having trouble while working on an Office 365 PowerPoint presentation. Now, in this case, you're going to leverage the endpoint agent to help you understand the employee's local network connectivity in their home or hotel or wherever, and also their user experience while trying to communicate with Office 365. So if you look at the red line, you go from the user through the endpoint agent, out through the router. You're bypassing any other type of cloud agent as you traverse the internet. You hit the router at the SaaS provider and are routed to the application. And when you really think about this, when you get this phone call, you have no idea what the home office network connectivity looks like. You don't own the internet connectivity, nor the SaaS connectivity, or even the application, right? It's completely hosted by someone else. So without this type of visibility, this type of scenario would be extremely difficult to troubleshoot. In the next flow, you want to make sure that a web-based application running in your corporate data center is accessible to external customers. So in this particular diagram, the corporate office and the edge location shown in the lower lower mid and lower right portions of the diagram are intended to represent not your corporate office or edge location, but somebody else's business, right? Your application is being hosted in the data center in the upper right corner. So in this case, we're going to leverage cloud agents for outside in traffic. Cloud agents can be in multiple distributed locations throughout the world, as shown here. Maybe the home office is on the East Coast of the United States, the corporate office is on the West Coast of the United States, and the edge location is on another continent. It really doesn't matter because Cisco and ThousandEyes have provided cloud agents, again, all over the world across all different types of networks and ISP tiers and service providers, etc., including broadband providers. So, so you get a good view of how whether or not users in a given location or a set of different distributed locations potentially sourced from all over the world, what their experience is when trying to access your centralized application running in your data center. Okay, finally, you want to make sure that an employee of your company who is at the corporate office can reach infrastructure as a service, services that are running in your public cloud. And so here, in the corporate office at the bottom middle, we see that the user is leveraging an enterprise agent, which is not installed on their laptop, but installed within the corporate office. It sort of intercepts their outbound traffic, which then, bypasses any kind of cloud agent as they traverse the internet, hit the router at the public cloud service provider, and then are routed to their infrastructure as a services. So obviously, this traffic flow leverages enterprise agent for inside out traffic, right? Meaning traffic starting inside your enterprise network and headed external. Now, are all of these traffic flows that we've shown the only traffic flows that are offered by ThousandEyes? No, but these are the most common flows and represent a majority of what businesses today are after when they wind up in war rooms trying to understand what went wrong. All right, so these are just a summary of many ThousandEyes use cases where the ThousandEyes platform can be of benefit. So starting at the top, we've got BGP target prefix route monitoring. So again, this talks about monitoring a specific prefix, its availability, the path that's used to reach that prefix, and whether or not there's any changes to that path. For content delivery network, you've got points of presence distributed, geographically to be in closer proximity to some of your user base, which increases application performance. So when you monitor those points of presence, the types of issues you can uncover have to do with whether users are being mapped to the closest point of presence for accessing content in that delivery network. Because if they're being mismapped, that could impact performance, and it can also help you uncover whether or not there's any kind of caching errors, right? Whether the caching that's happening in the content delivery network point of presence is actually working successfully to speed up user performance or not. For collaboration tools, again, these have to do with WebEx or Zoom. Obviously, if these are tools that your business relies on heavily, you want to monitor the endpoints of this application and understand whether there's a network problem on your network that is preventing users from accessing these services, or whether there's maybe something happening in the service provider or in the SaaS provider themselves. For the DDoS service providers, what we mean here is that when some malicious attacker, right, tries to attack your data center network, you may have a service that reroutes traffic to a DDoS service provider, which then scrubs all of the traffic, removes anything that's harmful, and then simply passes through legitimate traffic to your network. Sometimes this is done over something like a GRE tunnel. So again, you want to monitor the availability of such a service, because if you're attacked and the service isn't available, then the applications running in your local data center could go offline. So we want to know when our DDoS service providers are having issues, or whether we're having connectivity to those locations, so that when a DDoS attack hits us, we can successfully mitigate it and still keep our business applications online. For end user monitoring, again, that sort of just comes back to the end user or the endpoint agent installed directly on a user's laptop, so we can understand their local connectivity and the experience that they're having in their browser as they're accessing web-based applications from remote. Internet Insights and monitoring. Again, Internet Insights is a service offered by ThousandEyes that provides a macro view of events happening on the internet, whether those are ISPs or content delivery network providers, DNS providers, security as a service providers, and so on and so forth. How those events are impacting your business applications. We've already kind of covered infrastructure as a service and software as a service as we were going through our different traffic flows. For SD-WAN assurance, this is actually a really cool use case, right? SD-WAN solutions typically involve an underlay, an overlay, and a controller. The controller is where you configure the routing policy and which paths you want given business applications to take over the available paths on the underlay. When there's a problem, the SD-WAN controller can typically say, hey, we had a problem sending this, sending traffic for this particular business application over the primary preferred path. So we have switched traffic over to a secondary path. And the reason that we did this was packet loss. What the controller can't tell you is where that packet loss occurred on the underlay. And so how do you then restore the primary preferred path when you don't know where the problem occurred, right? So what we're saying here is that SD-WAN solutions typically don't provide visibility to the underlay, and that's something that ThousandEyes can monitor for you, so you can understand what problem occurred, where it occurred, and so you can go fix it and restore connectivity over the preferred path. And then web performance monitoring has to do with monitoring or visibility to traffic that's inbound to applications that you're hosting in your own data center, right? So we're referring to external customers' ability to successfully transact with your self-hosted applications. Now, in terms of ordering and licensing, it seems a little bit complex. It's actually fairly straightforward. The most complex portion about it is calculating the units for your cloud and enterprise agents. But when ordering ThousandEyes in CCW, what you'll do is you'll search TE sub, which stands for ThousandEyes subscription, because this is a subscription-based service. So TE sub is basically the part number. And after you add that single line item, you can edit options to configure the subscription to use the functions and services that you need. If you are going to leverage synthetic testing on cloud and enterprise agents, then you'll want to quote the number of units, which is represented by the part number TE units, needed for all your tests. Here, you're essentially signing up for an annual contract with a monthly budget of units for running tests. If you require help from advanced services and setting this functionality up, you'll want to quote ASF core TE units. And this is a flat rate, fixed scope project with predefined deliverables. Now, if you're going to leverage endpoint agents to understand end user network topology and user experience, you'll want to quote the number of laptops, which is TE users, where these agents are going to run. Endpoint agents don't consume units the way that cloud and enterprise agents do, which means when you pay for the endpoint agents, you're not calculating or assigning a monthly budget of units to run tests. Instead, you're just paying a flat monthly rate per endpoint agent. And again, if you need services from advanced services, if you need help from advanced services in setting up this functionality, then you'll want to quote ASF core TE users. And then finally, if if you're going to leverage Internet Insights service provided by ThousandEyes to understand macro level provider and service outages across important regions to you, then you'll want to quote TE Insights. Understanding internet events will help you correlate those events in terms of how they impact your business applications. Internet Insights comes bundled where you can select a package that contains a certain set of providers or services in specific regions. And you can purchase these packages in bundles of 2, 6, 12, or all packages. Obviously, the more you purchase, the steeper the discount. And if you need, again, help from advanced services and setting up this functionality and understanding how it works, then you'll want to quote ASF Core TE Insights. All right, so to wrap up this presentation, here are a bunch of ThousandEyes resources that will be useful to you. First, ThousandEyes.com. Here you can sign up for an account and start a free trial. By the way, when you get this presentation, all of the links are clickable. The Black Belt training is really good foundational information to get you started with ThousandEyes. There's a pre-sales track and a post-sales track. So when you click this link, you'll then want to click Hybrid Cloud on the far right, then click on the ThousandEyes tab, and you'll see the pre-sales and post-sales track. The pre-sales track has 2 phases, and the post-sales track has 1 phase. There's also Sales Connect, which is an internal Cisco webpage dedicated to ThousandEyes information for partners. So it has been exposed for partner access. Lots of good information there. You've got the pricing tool. This will give you assistance with pricing 1 of 5 predefined use cases. For custom use cases, there's an offline spreadsheet that we can make available to you. The Automator is a browser plugin for Chrome, which will attach to a valid ThousandEyes organization and account group using a username and API token within the account group, and then it will make all of the API calls necessary to deploy one of those 5 predefined use cases within a couple of minutes. So super useful. The endpoint agent, when you configure a new endpoint agent within the SaaS-based management platform, you're going to be asked to download and install some software. And when you install that software, if you're using Internet Explorer, the browser plugin for Internet Explorer is installed automatically. But if you're using Chrome, then it is not installed automatically. You need to download the browser plugin for Chrome and install it manually. So this is a link where you can find that. There's currently no browser plugin support for Safari or Firefox, but I think I've seen some indications that those are on the way. For your cloud agents, there's a list of cloud agents throughout the world which you can use in your tests. So that link will show you where those cloud agents live and the providers that they live inside of. You've also got the Internet Outages page, which is a map of Internet outages and associated information. And then finally, the ThousandEyes Recorder. And this is specifically to be used with transaction tests, so HTTP transaction tests. And essentially, this is an IDE that you install on your laptop. And when you start it up, it will begin by recording the points and clicks and steps on your screen and convert that using Selenium into a script that can then be cut and pasted into your transaction test. What's really cool about this is you can also simulate user delay in the actual transaction. And you can also gather screenshots of what the user would be saying during the transaction, even though the entire transaction is being automated and run from your cloud or enterprise agents. So hopefully that's a good list of resources to get you started. I want to thank you for your time and listening to this presentation. If you've got any questions, feel free to reach out to me. Again, my name is Dan, and I'm a data center TSA at Cisco. Thank you.